In this video, we're going to look at some different kinds of algorithms. And the first thing that you need to know is the definition of an algorithm. An algorithm is a systematic procedure for performing an operation. And we talked about the division algorithm when we were in Module 2, and we were doing some base versions. Also, and what we're going to do now is we're going to extend modeling to traction. So let's, for example, 39, okay? 23 at the top. About this, you may see some jerky motions in the video. Don't shut it down, just stay with it because you'll get to what you need to see. What we want to do is we want to look at thinking about processing in addition. So when we think about 3 plus 9, 3 plus 9 is 12, and we carry 1, and 5 plus 2 is 7, and 1's 8. So when we the addition algorithm, the way that we normally will do it, is one of the common ones, okay, but particularly elementary age. We model 3 up here, and 59 down here, that would be 2 longs and 3 units for 23. That would be 5 longs and 9 units for 59. Now, the concept of borrowing engages in the fact that we understand that a long is represented by 10 of these units. So if I take and I model 10 of these units, okay, then I can trade 10 of these units for one more long. And I'll put it over here. And then I have 2 units left. So this concept of trading 10 of these for one of these is the concept of what carrying means. So I'm trading. So think about that as a trading concept. Okay? So then we end up with 1, 2, 3, 4, 5, 6, 7, 8. 8 longs, which represents 80, or 8 rows of 10, and 2 units left, which gives me 80 plus 2, which is 82. So that is an algorithm for addition. Now, the concept of borrowing. Okay, so let's look at $30 minus 18. Okay, so let's start out with 30. 10, 20, 30. Okay, so there's 30. Now I need to take away 18. But there's a problem there because I don't have anything to take away except 10. I can't take 18. So what I have to do is I have to trade now this for 10 of those units. 2, 4, 6, 7, 8, 9, 10. So now I'm going to take this away. And so I still have 30 here, but it looks different now, okay? It's 2 longs and then 10 units. It's still exactly the same thing. It's still 30. All right, so now I'm going to remove 18 because I can do that. 18 would be 1 long and 8 units, okay? So I remove that, and I have left 12. Which is a really big deal because students have a really hard time with this concept of, okay, I'm going to borrow 1 from this, but it's really 10. So when we borrow 1, okay, that means we're going to take away. That was that concept of taking one of these away and trading it then for 10 units. Now, this is something that you may not have learned when you were learning how to subtract. You may have just learned to put the line and a 1. And that's what's so difficult, I think, for children to understand. Because we borrow 1 from this. That's actually a 10. So I put the 10 over there. And then it becomes easier for me to see because I actually did have 10 of those little units, so it's easier to understand. Now, I look at this then as 10 minus 8, which is 2, and 2 minus 1 now is 1, which gives me the 12 that I got for my answer. Okay, so base 10 blocks the addition and subtraction algorithm using the base 10 blocks. Okay, now you also will want to take a look at videos that are available in my math lab, the author videos that look at the left to right algorithm, the lattice algorithm, and the scratch algorithm. Now, I don't cover these. It's not that they're important, they're not important. It's just that oftentimes we provide children with too many ways to look at a model, okay? So too many ways to look at subtraction. So I'm providing a base model because if I have built students' knowledge of place value using base 10 blocks, then children are aware of how the blocks work and how to use those. So I typically will just show that model because too many models confuse children. Okay, so the subtraction algorithm we already took a look at. Okay, let's look at addition and subtraction from the perspective of the algorithm using other bases. Now, why is it important for students to look at other bases, and why is it important for you as students learning how to build a conceptual knowledge of the content to look at other bases? First of all, if you have a thorough knowledge of what base 10 is all about, then you can apply that knowledge to base 5. Or base 7 or base 12 or whatever. So let's take a look at the concrete model with the borrowing and trading and see if we can identify how to add in base 5. Alright, excuse me. Now we need to know that in base 5, see in base 10 a flat had 100, a long had 10, and a unit was a unit. So basically a unit is going to be a unit no matter what. But a long now, instead of having 10, it's going to only have 5. So if I could cut this in half, then I would have a long. Now, a flat will have only 25, so it would in essence be about a fourth, not about, exactly a fourth of the size of a flat. Alright, so let's see what that means. Okay, so now we're going to actually look at the physical model of 222 base 5 plus 231 base 5. Alright, in order to do that, students are probably not going to have access to base 5 blocks because we typically don't see those unless you actually make them for the students using some kind of cardboard, not cardboard, but cardstock and laminate. So the easiest thing to do is just model and go back and look at, again, what does it mean? 5 to the 0 is a unit, the next one is a long, and the next one's a flat. So this tells us I have 2 units. Well, let's start with the largest because that's the hardest to draw. So I have 2 flats. I have 2 longs, and I have 2 units. Okay? For 231, I have 2 flats, I have 3 longs, and I have 1 unit. Okay, now obviously these aren't to scale, but you can tell easily what the numbers are. So now let's combine all of those. So then down here, I have 1, 2, 3, 4 flats, and 1, 2, 3, 4, 5 longs, and 1, 2, 3 units. Okay, so now if a student has a thorough understanding of base 10, then, and the whole concept of trading, then we can look at this and say, okay, each of these flats represents 5 by 5, or 5 longs. 1, 2, 3, 4, 5. I have those. So I'm going to trade that long then for a flat. And I'm going to put an additional flat over here. Okay. Now remember that in base 5, I only have 0, 1, 2, 3, and 4. Okay? So I can't have 5. But what I could do is I could trade that for a cube that's 5 by 5 by 5. So that would be one big cube over here. Okay? That's 5 by 5 by 5. Alright, then if I do that, then I can get rid of these. And so I have this big cube and 3 little units. Okay, so now let's go through here and see how to write that then. So we've got, in the first place is your units, and I have 3 of those. In the second place is longs, and I don't have any more of those because I traded them here. In the third place then is flats, and I don't have any more of those because I traded it for the cube. So then I have 1 cube, and that's 5 by 5 by 5, and 3 units. So that 222 base 5 plus 231 base 5 is 1003 base 5. Okay, now, if you want to check this using base 10, you can change this number to base 10. Okay, let's just look and see what it is. Here I have 25 times 2 is 50. Here I have 5 times 2 is 10. Here I have 2 units. So 222 base 5 is 62 base 10. And 231 base 5 is 25 times 2 is 50. 5 times 3 is 15. And 1 unit. So that gives me 50 plus 15 is 65, and 1 is 66. So when I add 62 and 66, I get 68 base 10. Now let's see what this becomes. So this then tells me that I have how did I add and get 68? So 6 and 2 is 8, and 6 and 6 is 12. Is that a little better? Yes, I think it is. Okay, you all just have to forgive me. I make mistakes just like you all do. Okay, so then I look at this, and I have 5 to the 0 power. This represents 1, okay, or I'm looking at these here. So these are units, so I have 3 of them. And this is a cube, which is 5 times 5, which is 25, times 5 is 125. So I have 125 plus 3 is 128. So I did it with the model with base 5 blocks, and I did it by doing conversion to base 10 to just double check myself and make sure that that's exactly what it needed to be. Okay, now let's take a look at doing this the long way. Okay, and by doing it using the algorithm vertically, I would have 222 base 5 plus 231 base 5. And let's see if I get the same thing. Alright, so I can take and add 2 plus 1 and get 3. And this is obviously going to be base 5, so I'll bring that down. Now remember that the only digits I can write are 0, 1, 2, 3, and 4. Once I get to 5, I have to carry. Okay? Because that's like in base 10, I can write 0 through 9, and once I get to 10, I have to carry and trade. Okay, so here I have 2 plus 3 is 5. Alright, but I can't write down a 5 because it's not one of these digits. Okay, so I want to trade that 5 out, and when I carry it, or I'm trading out one of the 5 to the second, okay, or 5 to the first, and I'm trading it to a 5 to the second. Alright, so then this leaves me with nothing in this place now, because I traded it out and moved it. Alright, now I add 2 plus 2 is 4 and 1 is 5. Okay, but now remember I can't have that 5 again, so I have to carry it or bring it down here. And if I trade this out, I don't have anything left. So that my number that I actually have then is 1003 base 5. Okay, let's do another one, make sure we've got it. 1203 base 5 plus 2044. Okay, let's see what we're going to get here. Alright, obviously we're doing base 5 again. So we're going to have 3 plus 4 is 7. Now, can't do that. So this is like 5 plus 2, right? So if I need to write that, I've got 5, and I'm going to put that over here because I'm going to trade it, and I still have the 2. Okay, because 5 plus 2 is 7. Now, I've got 0 here plus 1 is 1 plus 4 is 5. But I can't write the 5 down, so I trade it and carry, and I don't have any left there. Then 2 plus 1 is 3. 2 plus 1 is 3. So when I add these two, I get 3,302 base 5. Okay? Okay, if we have a clear understanding of the concept of place values and the algorithm that we want to use to add, then we should be able to do now with base 10. So let's see. Base 7, I'm sorry. So let's do 26 base 7 and 263 base 7. Now, I don't know why I wrote 7 down here. We have 7 digits, so we don't include that 7. Okay? So then we're going to add. So we're going to get base 7. Now remember, we carry anything that's 7 or more now. Alright, so 6 plus 3 is 9. Can't do it. 9 is 7 plus 2, so we carry that 7 as along and leave the 2 because there's 2 that won't go. Then I have 6 plus 2 is 8 plus 1 is 9. So then I have to, that's 7 plus 2, so I have to carry that, in this case, carry another long over another flat, which would be 5 of those. So, excuse me, 7 of those. So 7 plus 2 again is 9. Now, 2 plus 1 is 3. So I have 322 base 7. Okay? Just remember, whatever you carry, whatever the base is, when you carry it, you're carrying 7. And then you write down what the remainder is once you take that 7 away. So this was 9, so 9 minus 7 is 2. Then when I added here, I got 9. And again, 9 minus 7 will be 2. And I had to carry the 7. And then 3 plus 1, 2 plus 1 is 3. Base 7. So think about what that means then. Okay, so this one represents 2. This one represents 2 times 7. And this one represents 3 times 49 if you want to check it, because 49 is 7 times 7.